Well, hello there. It's wonderful to be with you today. Thank you so much for attending my talk on Not Your Grandmother's Embedded Systems. Since we are talking about embedded systems, and we're going to be talking about the ones in the past and the ones that are coming in the future, it might be a good idea if we all actually agreed on what an embedded system is. This is a tricky question, actually. I've been to quite a few embedded systems conferences and talked about this subject with many engineers. And the one thing that is common is that no one can agree on what an embedded system is. Now, some people would say that an embedded system has to be digital, it has to be electronic, it has to contain one or more processors, it doesn't have a user interface, and it's out of sight and out of mind. And what I mean by that, about 20 years ago, I thought the best definition I heard of an embedded system is one that you don't even know it's there until it stops working. Now, of course, things have changed in the last few years. Embedded systems are everywhere. They surround us. We touch them every day. Some people would actually say something like a clothes washer was an embedded system. I would say it's a clothes washer. The controller would be the embedded system. And in this example, I'm trying to indicate an electronic controller with a microprocessor. And we use that controller to set the duration of the wash cycles, the amount of water, the temperature of the water, the speed and duration of the spin, and so on. Supposing I were to take that controller out and replace it with a clockwork controller, which is the sort of thing that my aunt used to have when I was a kid. If that controller does exactly the same thing as the previous controller, setting the duration of the cycles and the temperature of the water and everything, does that make it any less of an embedded system? The fact that it's mechanical and not electronic. This is a classic example for me. This is a centrifugal ball governor from 1788. And the idea is it's attached to a steam engine. As the steam engine goes faster, the balls swing up to the side with centrifugal force. And that controls the amount of water going into the steam engine and thus the speed. So this is an analog mechanical system that's performing a very sophisticated proportional integral derivative control function. And it's a smaller function within a larger system. So I would say that this was indeed an embedded system for its time. Now, I'm not arguing that today the majority of embedded systems are digital, are electronic, and have control microprocessors. I'm just saying we should keep an open mind about this sort of thing. We also tend to think that we've invented everything recently, like our 7-segment displays, for example. But in 1898, a guy called Mason submitted a patent for a 21-segment display. Each display segment had got an incandescent light bulb, and there was a complicated electromechanical switch, which you could set by using electricity. You could set it to different stages, and it would light the various segments to display characters and symbols and so forth. Coincidentally, 1898 was the year that my grandmother was born. Just as a point of interest, some of my friends are actually resurrecting some 21-segment Victorian displays. This is an example from my friend Steve Manley in the UK. And of course, we're using a microcontroller and tricolored LEDs and everything. But these are starting to look very, very tasty indeed. So returning to my grandmother, 1920, an era of questions. This is my grandmother and my grandfather when my grandmother was 22 years old. And as you can say, she's got an inquiring mind. She's asking, what is an embedded system? So this is 1920. Coincidentally, that was the year of the first commercial radio broadcast in the world. That was 100 years ago today. Well, not today, but this year. And when you say 100 years, that seems like an awfully long time ago, deep in the mists of time. But when I think about it, this was only 37 years before I was born, which brings it an awful lot closer for me when I think about it. 1948, here's a young boy seeing a television in a shop window for the very first time. This was only 9 years before I was born. And when I was a young lad of 3, 4, 5, this was the sort of television that we used to have in our house. This is the sort of telephone we had in our house in the 1960s, rotary dial, tied to the wall. I had some aunts and uncles in Canada, and we called them at Christmas, but we couldn't make a direct call. We had to go through the operator for everything apart from local calls. It wasn't until 1970 or 1971 that we could actually pick up the phone and dial all the way to America or Canada by ourselves. And now we don't think anything of this. In fact, just before this conference started, I used my cell phone to call Finland, which would have staggered my grandmother, I'll tell you that. 1999, this would have been the state of the art with regard to a cell phone with a camera capability. And this is actually a real thing that somebody created back in 1999. It wasn't until the year 2000 that the first cell phones with cameras as part of them appeared in Japan, and 2001 before they appeared in the USA. And I remember at that time, I didn't own a cell phone myself, but the people who did would walk around saying, why do I need a camera in a cell phone? All I want to do with my phone is make telephone calls. Of course, if they could see us now, just 20 years later, the cell phone, the smartphone, is the Swiss Army knife of our tools. MP3 players, audio recorders, cameras, audio books, global positioning system and stuff. The reason I highlighted ukulele tuner is a couple of years ago, I built myself a ukulele. And the one thing you've got to do when you build a ukulele is tune it. And I was going to go down to the local music shop and buy myself an electronic ukulele tuner. And then suddenly I thought to myself, I wonder if there's an app for that. And by golly, there is an app. If you go on the iTunes store or the Google store, the Android store, and do a search for ukulele tuner, you'll find that there's a myriad ukulele tuners, which is quite staggering to me, to be honest with you. So what I thought I'd do, we've only got a short amount of time, so I thought I'd tell you about some of the interesting things I've seen recently, and then we'll talk about what's going to come down the pike for the future. So what we're going to look at, first of all, is stuff that's available now today. This one from Level Technology is hot off the press. It was only announced yesterday. At the moment, when we send messages between our devices, we use MAC addresses. The problem with MAC addresses, as we all know now, is that nefarious players can spoof them. So if you're in a coffee bar using Wi-Fi, somebody could spoof the coffee bar's Wi-Fi MAC address. And you think you're talking to the coffee bar, but in fact, you're talking to somebody who's recording everything that you're doing. And you might say to yourself, well, I'm going to use VPN, which sounds great, but VPN doesn't actually monitor the lower levels of the OSI stack. It only comes into play at about level 4. So all the data is still transparent to anyone who wants to look at it, unless you encrypt it and everything. So this company, Level, have come up with something. It's non-intrusive. You don't have to load anything onto your smartphone or your computer. It's the Wi-Fi router. Each device has got a digital signal, and this is based on all 7 layers of the OSI stack. Their software, which can be uploaded to the router overnight while you're not looking, can extract a digital fingerprint from every device that's talking to it. And every cell phone in the world, even if they're all off the same production line at the same time, they all have a slightly different fingerprint, just like our fingerprints are different. So this technology, like I say, was announced yesterday. I don't know where it's going to spread, but I can see a big future for that one. This is just a random thought for the day. Top left, a 5 megabyte hard disk drive from 1956. Bottom right, a 1 terabyte micro SD card from 2020. I remember using the 1.7 or 1.4 megabyte little floppy disks, and we thought they were the bee's knees compared to what came before. Another random thought for today. These are the elements in the human body. This is all it takes to form somebody like me or you. The 5 most common elements are the ones in green: hydrogen, oxygen, because of water, of course, and so on, calcium, carbon. By comparison, these are the elements in one of today's integrated circuits. So in this context, you could say that an integrated circuit is actually more complicated than a human being. Gartner, the marketing firm, came up with something called the hype cycle, which is now pretty well known. It's for emerging technologies. We start with an innovation trigger. Then we get to the peak of inflated expectations where everyone's been talking about it, but there's nothing really there yet. And then we go downhill to the trough of disillusionment and then the slope of enlightenment and so forth. In 2014, which is only 6 years ago, artificial intelligence and machine learning weren't even a blip on the horizon. Just 1 year later, in 2015, machine learning had already crested the peak of inflated expectations. And if you look around today, 5 years later, artificial intelligence applications are everywhere. It's unbelievable. Almost every modern system has got some sort of machine learning capability. And this used to be the purview of people with size 16 brains and 4 doctorates and everything. But now it's open to everybody. This system on the left-hand side is an AI system that I created here in my office a couple of weeks ago, well, maybe a month ago. It's using a tool called NanoEdge AI Studio for Cartesium. The processor there is an ARM Cortex M0 Plus, and it's actually an Arduino little Bluetooth board. What I'm doing is using the black device is monitoring the current to a vacuum cleaner, and we learn when the vacuum cleaner, the normal signals, the blue dots, are when the vacuum cleaner is empty and working as planned. The red dots are when the vacuum cleaner bag needs to be changed. NanoEdge AI Studio, you gather all the data, you press the go button, it experiments with different building blocks and comes up with the best system out of 500 million possibilities, and trains itself to this particular vacuum cleaner. And the resulting system for this particular example took 2 kilobytes of memory in my processor. And this is something I did in a day. So, wowzers. In addition to using off-the-shelf microcontrollers like the ones based on ARM Cortex M-series processors, a load of people have now started making specialized chips for inferencing and machine learning and so on. This is one that came out just a couple of weeks ago from FlexLogic. You may know them for their embedded FPGA material that people use on SoCs. And they've taken that FPGA material and tweaked it a bit, and they've come up with their own line of InferX ICs that perform inference in a very, very fast and power-efficient manner. And like I say, they announced only a couple of weeks ago. These people, Deep Vision, announced only a couple of days ago. These are vision processors intended, vision-specific AI processors intended for use at the edge, less than 2 watts, incredibly low latency, and useful for all sorts of applications like robotics, surveillance, and so on. This is a company called Algolux. They specialize in computer vision systems, and in particular in helping other people to create their own computer vision systems. One of the things about a computer vision system, you've got the lens, you've got the sensor, you've got the image signal processing pipeline, And eventually you get to the artificial intelligence inferencing engine. The problem is that the whole pipeline has to be tuned. And the problem there is that the people who tune these things, which can take weeks of effort, sometimes months, they tune it for human vision, which may not be the best thing for artificial intelligence. It's strange, but you might want to change the image in a slightly subtler ways to make the artificial intelligence job easier. And so what algorithms do, their latest thing, they do all sorts of things, but the latest thing is this EOS embedded perception software. And this fine-tunes the whole, it uses artificial intelligence to fine-tune the whole imaging pipeline for artificial intelligence, with the result, as you can see in this image, that it can detect things in the image. I've walked around in nights like this, where it's really hard to work out what's going on. And they can spot the most minuscule things, well worth a look at if you're in this area. This is something that just mind-boggled me. On the left-hand side, we've got 3 images, and these are incredibly highly pixelated, 8 by 8 pixels. I think this was Facebook that did this. The middle images are ones that their AI system recreated based on those pixelated images on the left. And what they did was to go through, it might have been Google, actually. They went through millions and millions of images and looked at what sort of features in those images would create this sort of pixelated pattern on the left. And so they backward inferred what the person would look like. And the image on the right, so this is still pixelated. I mean, it's probably 128 pixels for the middle image. The one on the right is the photo of the real person. And this just staggers me how close they got from that original pixelated image. And it makes you think about surveillance cameras with a really blurred image in the future. They may be able to look at that blurred image and still pull out an image of a real person. This is something I saw a couple of years ago, actually, a prototype for smart glasses. Obviously, this isn't something you'd like to wear in public, but it's a prototype. And the thing is, these are auto-focusing. They're looking at the lenses in your eye. They can tell what you're looking at, whether it's in focus or not, and they can correct themselves. So whatever you look at, I'm short-sighted. So if I look down here or if I look up here, things are in different focuses. With these glasses, whatever I'm looking at, it will always be in focus. And I can imagine tying that into like an augmented reality headset or something. Until recently, I'd actually thought that we already had MEMS speakers, because you see MEMS banded around all the time. But it turns out that even MEMS speakers until recently actually had some, it was a mix of MEMS and discrete parts, and they had to be selected and connected together by hand. Just a few weeks ago, XMEMS announced the world's first monolithic MEMS speaker. And these will appear in all sorts of things. The thing is that they've got the same tolerances as silicon chips or any MEMS sensor. So you can just pick 2 up and they're matched already. So these will find their way into earbuds and headphones and all sorts of things. And again, think earbuds or headphones on virtual reality systems. This is a company called Scyware.com. The watch and the smartphone are there just for comparison. The device of interest is ringed in the red ring. These people make material sensors. This uses near infrared, and it can detect what's in a material. So all they do is make the chip and then sell it to people to make devices with, like soil samplers or food samplers. But you can imagine that in the not too distant future being embedded in a wristwatch, shrunk down a bit further, embedded in a wristwatch or in a smartphone. And when you go out for a meal in a restaurant, just holding your smartphone or your watch over the plate of food, and you've already told it that you're allergic to seafood and peanuts, for example. You don't need it to tell you about things that you're not allergic to, and it tells you, this dish has got peanuts in, it's got gluten in. It could even spot salmonella or botulism, which could be incredibly useful. This is a company called VotalZoom who make industrial communication systems. I'm sure you, like me, saw 2001: A Space Odyssey with the HAL computer lip reading the two astronauts when they were talking about turning it off. Well, this technology is a little bit simpler, a little bit similar. So you have a person talking in a very noisy factory environment. So the signal is a mixture of their speech and all of the surrounding noise. But this particular vocal zoom sensor, and they make all sorts of things, shines a laser light onto the person's face, and it can detect the little fluctuations in the cheek and the nostrils and everything when you're talking, and it uses that additional information to filter out the sound from the noise. So somebody else listening to the filtered sound, say with headphones, would just hear a perfectly clear voice, no background noise at all. One of the big problems that we have with things like our smart speakers is the cocktail party problem, which is when there's a whole bunch of people talking at the same time. There's a company in the UK called Exmos, and they've got these multiprocessor chips, and they've also got the most amazing algorithms to process the sound. And they can disassemble a sound space, so you can have a room full of people talking. They can identify all the individual voices, and once they've identified them, they don't know who that person is. They just know this is voice 1, voice 2, voice 3. They can track them, each person, as they're moving around the room, even if they're all talking. And you can filter it out and say, I want to listen to voice 3 and voice 2, and just hear that one conversation with all the other noise removed from it. This is a company called Immervision. They do all sorts of things with optics. They've got more optical PhDs than you can swing a stick at, but the PhDs work with engineers to make real-world products. One of the things they've just announced is something called the JOICE Human Perception Project, and they're soliciting people to come in and work on this JOICE project with them. And the idea is that you get all sorts of sensory data. They do wide-angled lenses. With these eyes, you can get like 180 degrees field of view, and they've got another camera in the back of the head to give you a 360. But they tie in all the other sensory information like sound, smell, vibration, anything else you detect. They tie it to the video on a frame-by-frame basis, which makes all sorts of analysis possible. They're aiming to give robots human-level perception in the not-too-distant future. And yeah, who knows where we're going to go with that one. This is a project from university in Auckland called Baby X. They've now spun off as something called Soul Machines. And this is a computer-rendered version of a baby that's learning from his father, who's saying, Dada, say Dada, say Dada. And when the baby learns to say the right sound, and the father's going, yes, yes, and the artificial intelligence is happy because it's achieved a goal. It's somewhat frightening and disturbing to watch, to be honest with you. So this is where we come into an area that I'm particularly keen on. Augmented reality is where you augment a real scene with additional information. Diminished reality is where you subtract information like color, objects, sounds. Virtual reality, completely computer generated. Augmented virtuality is when we add real objects into that augmented scene, virtual scene. Supposing you had all this information, mixed reality in a headset, would you wear these goggles in public? And you might say no, because I'd look stupid. But fashion's changed. You know, Dr. Spock and Lieutenant Uhura wearing these earpieces back in the 60s and 70s looked really weird. But now people walk around with the most amazing things stuck in their ears, and we don't think anything of it. So will this sort of headset be the Swiss Army knife of tomorrow? Can you imagine your headset with GPS and AI and material sensing? So when you sit down for a meal, the headset says, hey, be careful. This food's got botulism in it or something. I personally think that this sort of combination of mixed reality and artificial intelligence is going to transform the way we interact with the world, our systems, and each other. And things will shrink. I mean, in the future, this could shrink as far down as being a contact lens, for example. My mother didn't get electricity in her house when she was a little girl till about 1943. My grandmother, before they had electricity, they had the gas lights on the walls. And gas used to leak out if you weren't careful. And my grandmother was worried about electricity leaking out of the sockets. So she used to cover the sockets with sticky tape to keep the electricity in. A few years ago, I was in England visiting my mother, and I bought her an iPad and a gift card to Amazon. And she said, "What should I buy?" I said, "What do you want?" And she said, "Well, an electric kettle and toaster that matched would be nice." So I said, "Well, let's go on Amazon and have a look." And we found a set that she wanted, and she ordered them, and it said, "Oh, they'll be here in a couple of days." And I said to her, "What would my grandmother have thought to see you sitting here with your iPad, talking to a wireless network, and ordering an electric kettle and an electric toaster?" And my mother said, "Your grandmother wouldn't have understood any of this. What would have totally amazed her would have been the thought of an electric kettle and an electric toaster." So these would have been the peak, the pinnacle of embedded systems as far as my grandmother was concerned. So what does the future hold? Well, if you ask me in 10 or 20 or 30 years, I'll tell you, because as we all know, hindsight is the one exact science. Here's a guy, Sextus Julius Frontius, from about 2,000 years ago, who wrote down, "Inventions have long since reached their limit, and I see no hope for further development." As far back as, or as recently as 1888, this astronomer said that there was little left in the heavens to discover. Of course, this was 27 years before Einstein's theory of general relativity, which led to black holes, quasars, pulsars, and so on. 36 years before Edwin Hubble discovered that the Milky Way wasn't the only galaxy in the universe. There were, in fact, billions of other galaxies. This physicist in 1894 said that the most important fundamental laws and facts of physical science have all been discovered. It's unfortunate this was 3 years before we discovered the electron. So I think it would be a very foolish person who would predict the future in this case. But I absolutely believe that things are just beginning to ramp up, that in 10, 20, 30 years' time, if you think how far things have come in the last 20 years or 50 years, I think the next 10, 20, 30 years are going to be absolutely incredible, and I can't wait to see it. You okay? I should have told you I was stopping. So I'm afraid that's the end of my presentation. We're almost out of time. We have just 2 minutes, I'm afraid. But if you've got any questions, please feel free to chat them into the Q&A tab on your window, or you can email me. I can't guarantee an immediate response, but I can guarantee a response. So thank you so much for listening to me waffle on. And I hope it gave you a few things to think about, and I'd be interested in hearing your thoughts as well. So it doesn't just have to be a question. I can't guarantee. I'm sorry, Devon? I'm not sure if we're out of time. I thought I heard somebody talking to me. Oh, I'll type back. Thank you so much for joining me. I'm looking at all the comments popping up here. I wish I could have talked for longer. Much like my mother, the real trick is getting us to stop talking.